Here's the problem, using the RAF on formula type problems. I often get asked, well, how do you use the RAF when we don't have any numbers or we have little numbers and we're supposed to still solve for something? Well, we treat it the same way. I've specifically tried to highlight, in this case, the variable we're going to solve for, which is the W. I've put that in red and everything else in black. One thing that we can use is what's called the symmetric property when we start. I'd really like to have this W over on the left-hand side of the equal sign to start with and move things around. So what I'm going to do is I'm going to rewrite this problem. And I'm just going to rewrite it as 2L plus 2 red W, because that's my variable, equals P. Notice all I did was I kept everything in exactly the same order. I just changed which side of the equal side they're on, and there's nothing wrong with that. That's called the symmetric property. Now when I apply the RAF, I will treat everything in black like a number, and the red will be my variable. So here we go. Letters on the left. So the first thing that's going to move, these right here, are going to move over because my letter is already on the left-hand side, so I'm going to move my numbers to the right, so I'm moving over a negative 2L. And since it's not really a like term with the P directly, I'm going to put it off to the side of it. So now after I combine what like terms I have, I get my 2W equal to my P minus 2L. Well, how am I going to solve for W? By simply dividing both sides by 2. Now notice on the right-hand side, I divide that entire amount by 2. My 2's on this side will cancel, and my RAF has taken me right to my answer of W equals P minus 2L, all divided by 2, and that is how we use the RAF when dealing with formulas. In this case, by the way, just so we know, this is the formula for perimeter equals 2 times the length plus 2 times the width in a rectangle. So if I wanted to find the width, I take the perimeter minus 2 times the length and divide that amount by 2, and that'll take us to my answer. Let's try another one. Move my screen up for us a little bit here. Let's say I have the following. I'm going to take volume equals 1/3 of pi r squared, and I'm going to solve this one for h. Typical way that you'll see the volume formula written, with symbols even, using pi in this particular case. But again, notice I highlighted the variable that we're going to be solving for in red. I can start off by using the symmetric property by rewriting my problem so that it will look like this. 1/3 pi r squared h equals my volume. And I'm going to walk us through very systematically. Notice there's no addition or subtraction in this, so there's really no wrapping of moving something over to the left and something else over to the right. In this case, I'm already right to the multiply divide stage. Some people get a little confused by this because they try and do too much at one time. So I'm going to take it step by step. First thing I'm going to do, I'm going to try and get rid of the 1/3 and change that to 1. How am I going to do that? I'm going to multiply by its reciprocal, which is 3/1, or multiplicative inverse, in which case that'll just become a 1. On this side, I'm going to multiply by that same thing. But already thinking ahead, I know that 3/1 is just the same as 3, so I'm just going to write the number 3 as opposed to writing it as a rational number 3/1. That now leaves me with this. Pi r squared h is equal to 3 times v. Usually we put the numerical part in front of the variable. Well, this is just a multiplication problem now, and the reverse of a multiplication problem is to divide. Dividing. Remember, pi is a number. It's the ratio of a circumference of a circle to its diameter, often referred to just as 3.14, but that's just a number. So I'm going to divide this side by pi and by r squared, the radius squared. I'll do the same thing on this side. I'll divide both sides by the same thing to keep it balanced. So that now at this point, what will happen? The pi's would cancel out, the r squareds would cancel out, and I am left with an h equal to, and then I have this 3 times the volume all over pi r squared, and that's how we use the wrap to also work with formula problems when numbers aren't necessarily as prevalent as the variables are.